Hi folks, in today's lesson we're going to be learning about the tangent ratio. This is a video that goes alongside two other videos, the sine ratio and the cosine ratio. We're going to be using the tangent ratio today to be finding a side, so let's crack on and get this job done. Trigonometry means three-angled measure, and we're dealing with angles in triangles. And the triangles we are looking at are going to be right-angled triangles, and we'll be given one length and one angle in the triangle, and we're trying to find the length of one of the other sides. Here is a right-angled triangle with one of the angles marked in at C. Imagine the angle were an eye, and the eye of the angle always looks at the opposite side. The right angle always looks onto the hypotenuse, and the third side we call the adjacent. It's really important you know how to label the three sides of the right angle triangle, either opposite, adjacent, or hypotenuse. Here's another example. There's the angle marked in at A. Imagine that was an eye. The eye looks out at the opposite side. The right angle looks onto the hypotenuse, and the third side is the adjacent. Once we have the sides of our right angle triangle labelled, then we can look at the tangent ratio, and the tangent is the ratio of the opposite side to the adjacent side. In this example, we've got the angle marked in at C. The opposite side to that angle is the 11 centimeters, and the adjacent side to that angle is 19 centimeters. So given that tan of the angle C is the opposite divided by the adjacent, that's 11 divided by 19. Here in this triangle, we've got the angle marked in at A, so we've labelled our three sides. Tangent is a ratio of the opposite divided by the adjacent, and where we have an opposite of 25 centimeters and an adjacent of 16 centimeters, that will give us a ratio that the tan of the angle at A will be 25 divided by 16. That's the opposite divided by the adjacent. Let's apply what we know so far about the tangent ratio to this example to solve the problem, which is trying to find the length AB marked in as X on the diagram. To the angle at C, X would represent the opposite side. Remember, the eye of the angle looks at the opposite side. So X would represent the opposite side, and BC, which is a 12 centimeters, would represent the adjacent side. So tan 32 is opposite over adjacent, that's X divided by 12. Multiply both sides by 12 to leave X on its own. Tap that into our calculators, and we're going to round off in this case to one decimal place. Here in example 2, we have the angle marked in at A, and to that angle, X would represent the opposite side. 20 centimeters would represent the adjacent side. So the tan of the angle is opposite divided by adjacent, so that would be X divided by 20. Multiply both sides by 20, tap that into our calculators, and once again we round off, in this case to one decimal place. In example 3, with the angle marked in at B, just be clear which the sides are. The eye of the angle, as ever, looks at the opposite side, so that's 8.9 is the opposite. The right angle looks onto the hypotenuse, which means the side marked X is the adjacent side. Tan of the angle is opposite divided by adjacent, so that would be 8.9 divided by x. Multiply both sides by x to get rid of the fraction, and to leave x on its own, we have to divide both sides by tan 31. Tap that into the calculator and round off to 1 decimal place. There is a little shortcut which is shown on the screen. T represents tangent, O represents opposite, and A represents adjacent. It's telling us that the tangent is the opposite divided by the adjacent. When we wish to find the opposite side, we put our finger over the O in the triangle and we're left with T and A next to each other. In maths, when you have two letters next to each other, that means multiply by, so that's telling us the opposite is the tangent of the angle multiplied by the adjacent side. However, if you're trying to find the adjacent side, you would put your finger over the A, and the adjacent then would be opposite divided by tangent. Let's try and apply the shortcut then to example 2. With the 59-degree angle marked in, x is the opposite side. So we put our finger over the O for opposite, and it tells us that the opposite side is the tangent of the angle multiplied by the adjacent. So that's 20 times tan 59. Tap that in our calculators and round off to 1 decimal place. Similarly, applying the shortcut to example 3, in the diagram, the angle marked in at B, 31 degrees, tells us that x is the adjacent side. So we're trying to find the adjacent side, so we put our finger over the A, and it tells us that the adjacent is the opposite side divided by the tangent of the angle. So that will be 8.9 divided by tan 31. Tap that into our calculators and then round off. Let's apply what we've learnt then in a recap. The tangent ratio is a ratio of the opposite side to the adjacent. We need to know in a right angle triangle how to label each of the sides. So remember, the eye of the angle looks at the opposite side, the right angle looks onto the hypotenuse, which means the third side must be the adjacent. The tangent ratio is the opposite divided by the adjacent, and we can use the TOA triangle as a shortcut. If you are trying to find the opposite side, put your finger over the O and you're left with T times A, which means the tangent of the angle times by the adjacent. If, however, you're trying to find the adjacent, put your finger over the A for adjacent and you're left with opposite divided by the tangent of the angle. And if there's anything about this you haven't understood, just watch the video back. If you have understood it, that's great, because that's the job done.